Alrighty, for this one, I'm just going to go down some of the problems that I think that might be the trickiest or the most complex with a bunch of steps. But it should be relatively easy, and I will skip the ones that you should know, hopefully. Alright, question 3. The average energy of an X-ray beam at 72 kVp on a 3-phase. So this one has a formula, the triangle formula. You have your kVp separated by, let me just get this. So you have two generators. You have a single phase and you have a 3-phase. Your single phase is 30%, 3-phase is 40%. And your average energy, or your effective energy. I know, crappy triangle. What you basically need to know is a single phase, 30%, 3-phase, 40%. So you're at 72 on a 3-phase, so 3-phase is 40%, so you multiply that by 0.4. We get that because 40% conversion is 0.40. Remember, King Henry died by drinking chocolate milk? You move the decimal over, tens, hundreds, because percentages are out of 100. So 40% out of 100, move it over, tens, hundreds. So 72 times 0.4. Pop in the calculator. It's going to be 28.8. So that would be your average or effective energy beam. So 28.8 keV. Pretty sure. Yeah, keV, because we're talking about, actually, yeah, keVs. So make sure you include your units, especially you, Morgan, who just loves to tell the number without units. Yeah, include your units. So this is 28.8 keV. Next question, it's really easy again. 92 kV times, again, 3-phase, so 0.4, which would then give us 92 times 0.4, 36.8. So 36.8 keVs. Alrighty. That's the first few problems. I'm going to put a little line so separate everything. Next problem, if exposure to a patient is 25 milliroentgens at 60 kVp, what would their exposure to at 70 kVp? So which formula or stuff we're using, triangle we're using, sorry, would be the kVp triangle. So you have your intensity 1, which would be your milliroentgens, over intensity 2, yeah? Which should give us, let me just make sure I'm telling you guys correctly. Where's my paper? Nowhere to be found. Wait, where did my paper go? Oh yeah. Pretty sure it is indirect or inverse. I can make sure, yep. It's direct, so kVp 1 over kVp 2, which I'm pretty sure is the same as, yeah, okay, yeah. Again, you square it, boom, bang, you got that. So with this, you have 25 milliroentgens, so 25 over x, because again, 25 milliroentgens, your intensity 1, that's your first intensity, 25. 60 kVp is your kVp1, so 60 squared at 70 squared. And yes, there's a lot of math involved. So 60 squared would give us 3600 over 70 squared. If you can do it in your head, great. I just want to make sure you do it on a calculator, because I will do it on the calculator, especially on a test, because you can never be too sure. 4900 equals 25 over x. And again, just cross multiply. So 25 times 49. 100 would give us 1,22500 equals 3600x, and then just divide. which give us 34.027. And again, make sure you have your units. So milliroentgens, 34.027 milliroentgens. Now you can round up if you want to. You'll probably take rounded up or not rounded up. Don't matter. That'd go same with the next problem. Same way you work it out. Let's see, do I want to work it out? Yeah, might as well work it out for y'all. So, set up the formula, 30 milliroentgens. First KBP is 70 squared. Second KBP is 90 squared. So again, square 70 in your 90s. So 70 squared gives 4,900. 90 squared, 8,100 equals 30x. Cross multiply. So multiply this by 30. So this goes 243 equals 4,900 x. Divide this from this. So you type in this number and divide it by this number. Divided by 4,900, which give us 49.59. Again, you can round up. Don't matter to me. Don't matter to him. Just make sure you have the units, milliroentgens. Whoops, not 49.59 milliroentgens. All right. So I think you should be able to do this one. If KBP is doubled, how many X-ray photons will produce? Remember, you square KBP, so 2 squared is what? 4. So you get 4 times or 1/4. Either one of those will work. If KBP is 15%, how many X-ray photons will you produce? That is 2 times, because you're only increasing by 15%. Alrighty. MA is 200, your time is 8 milliseconds. What is your mass? For this one, I'm just going to show you the formula, because this should be super easy. Mass is made up of what? MA and seconds, because milliamperes per second, or milliamps per, I don't think these are per, but milliamps seconds. So you already have your MA, you have your seconds. So your triangle is MA times time in seconds. That would give you your mass. That's the triangle you would use. Since this is in 0.8 milliseconds, so you take 8, and you know King Henry died by drinking chocolate milk. King Henry died by drinking chocolate milk. You're in milli, so you have to come 1, 2, 3, because this is your base. This is your seconds. Right here. So 1, 2, 3. Your decimal's behind, so 1, 2, 3 jumps. Your decimal's there. Fill in some zeros. So your 8 milliseconds is 0.008 seconds. Times that by 200. So 0.008 is 200. Would give you 1.6 as your mass. Again, make sure you have your units. 400 MA, 0.75 seconds. What is your mass? Super easy, just multiply the two numbers. Just make sure you're in seconds, not milliseconds or centiseconds. I mean, that's a thing, but make sure you're in seconds. Next one, 200 mass, 0.4 seconds. What's your MA? So you already have your mass. So your mass is already filled in. So you, in order to do this one, it'd be 200 mass divided by 0.4 seconds. Because again, you're still in seconds, so you don't have to convert anything. So just do 200 divided by 0.4, which would give us 500. Super easy. That's your MA. And again, your units, and you're in MA, not mass, because you already have your mass. You already have your seconds, you just need the MA.